Hello. For this particular video, we are going to investigate an exponential function word problem. The problem reads, the following exponential function f of t depicts the number of restaurants in t years since 2000. How many years will it take for the number of restaurants to triple? Round to the nearest hundredth. The function that is given is f of t is equal to 2 times the quantity of 1.33 to power t. Now, to answer this particular question, it is helpful to consider the general form of an exponential function. That is, f of x is equal to a times the quantity of b to power x. Now, if we compare the given function to this general form, we can see that a is equal to 2, b is equal to 1.33, and x is equal to t. Now, we need to determine what the initial number of restaurants is. And that can be determined by the value of a. So a is going to be our initial number because that is the value of the function when the independent variable is equal to 0. So when we set t equal to 0, we get that the initial value is equal to 2. So now we need to determine the number of years it will take for that initial value to triple. To triple a number, we will multiply that number by 3. So if we multiply 2 by 3, we're going to get 6. And that would mean that the number of restaurants is going to equal 6. So we're going to replace the f of t with 6. So that gives us the equation 6 is equal to 2 times the quantity of 1.33 to power t. Now, we need to solve this exponential equation. In order to solve this exponential equation, we will consider the number that is being multiplied to everything else on the right side. And this number is 2. So we should be able to divide both sides by 2. Now, we would not divide both sides by 1.33 because 1.33 is being raised to a power. We would instead divide the number that is being multiplied to everything else on the right side of the equation. Now, if we divide both sides by 2, we get 6 divided by 2 is equal to 2 times the quantity of 1.33 to power t, all divided by 2. Now, on the right side, the 2's would cancel out. And that will leave us with 1.33 to power t. On the left side, we have 6 divided by 2, which is 3. So we have 3 is equal to 1.33 to power t. Now we need to solve for t. When we have an exponential function, when we have an exponential equation, there is a formula that we can use to help us rewrite it as a logarithmic equation. This formula is b to power c is equal to a if and only if c is equal to log base b of a. In order for us to use this formula, we would need to consider that b is equal to 1.33, c is equal to t, and a is equal to 3. And if we rewrite it as a logarithmic equation, we get t is equal to log base 1.33 of 3. Now, not every calculator will allow for us to input a log with a base that is 1.33. So in order for us to approximate this using our calculator, we're going to take advantage of another formula, which is the change of base formula. Now, there are different versions of this formula. but this is one of them. And this is log base b of a is equal to natural log of a over natural log of b. Now, if we use this formula, we would end up with t is equal to natural log of 3 over natural log of 1.33. And if we input this expression into our scientific or graphing calculator, we would get that t is approximately equal to 3.852361. Now, let's keep in mind that we are asked to round to the nearest hundredth. So if we round it to the nearest hundredth, we can identify that 5 is in the hundredths place, and the number to the right of that 5 is a 2. So we would actually end up rounding this particular value to just 3.85. The reason is because 2 is 4 or below. So that means that this number will stay the same. And we would just get rid of the other digits on the right. So we end up with 3.85 years. And that is our answer.